Okay. All right. So if you go into those 101 source main, you should have the solution we left um, the other day, a week ago. Um, we had some issues at the end of the session because it turned out that the day before training, I tinkered with Cresio and I succeeded in completely broken it. So this is what you should have in your cargo 2ML. Either you can clone or you can just copy and paste this these
How
dependencies, and then that will work. Go ahead.
how would I clone it? Because that would be the better way to do it, right?
Yes,
Like
let
or
me
more
give
in
you.
educational.
Sure. I just need to give you that. I would put in Slack again. And it's git clone. Voila. Like this. And you will be up to date with me. So that's the command to clone a Git repository. So we're going to work in the main branch always, but we can have a look at the solution and discuss that. So I've asked if you could look at two things. One being trying to um, getting an image like this one that you may see here, because otherwise you see just a dot. I don't know if you try that, some of you. And the idea is just to modify the builder and the detector um, using the detector method for the Shakerman builder. And that is found by going to Client CEO, Optical Model Builder, and here we look at options, and the optical model options, and we go to Shakerpan options, Shakerpan builder, and that sends us to Cresio. And then you have this detector method where you can set some parameters. I realize that there's no documentation because the meaning of this parameter. I should really improve that. But to really set the size of the detector frame is really NP, it's framelet which changes. And OSF is the oversampling factor. What that means. So you can also play with that. And here I put it to 4. The default is 2, which is Nyquist sampling. So like 4, so that gives us a better a smaller image with a larger resolution, and that leads us to a nice and resolved image. Okay. And any question on that?
It's just a comment. I updated the version of the Cresio and the DOS actors to the ones we have in the repository. Then everything is fine. So the issue was that I was using an updated version
Okay.
of the DOS actors.
Perfect.
And another comment, I run it without changing the properties of the detector. And I think that the dot is so small that I cannot see my screen. So I see just the dark blue background without changing the.
Yes, without changing, you see just a little dot because you have 512 by 512 image. So you need to
Yes.
really zoom in to really see. So that's why I suggested to you to try to do that. And then so here I put a 64 by 64. And on top of that, I change that to, if I go back that to none, cargo run, just on the size of the frame, Segmentation. Oh yes, we need to do something. I always forget myself. We need to set GFT modes path always to that value, PWD data.
So I just did a cargo run on my computer, and it was compiling for a while, and then first it was downloading, then compiling, and then running. And then it says segmentation fault.
Yeah, I get the same error message because I forgot
Okay.
to do that. Up, I put it in Slack.
Oh.
You need to tell him where to find some data related to the optical model. Okay, and if you let it run, you will see. And if we load the image again in the Jupyter notebook, yes, use this one. And now the image, maybe the image is a bit smaller because we decrease the resolution again, not by changing the size of the image, by changing the size of the pixel. The pixel. If you put 4 here, the pixel are half the size. If you, like it was before, it was half the size of what it was. That was one thing. I don't know if there's any question on that. Otherwise, I'm going to move on to the next thing I asked was to try to retrieve to get the wavefront error RMS with a new logger here. And basically, it's using the get method. Because the logging client has to be put in a mutex, we need kind of locking it and then wait for the runtime to give us a handle to the logger, and after we can use the get with the name of the field as a string, and then we get this time a vector of vector. So the first vector corresponds to the time. It's printed here. You see we have a vector of 5, and each time we have the data. So it's how it's get. And the way I was saying to get to that was going to the Arrow client.
I still
Yes.
get the segmentation fault. Did you do the export in the DOS 101 folder? Or?
Yes. Do you have a data directory in the DOS 101?
I don't think I do.
That's why it's missing the data directory. You need to create a data. So
just create a new folder data.
Yes. And if we go to those actors, I think. How is it done? Where is it? Information.
Still the same.
Oh yes, you need to put some data in there. If you have not, I'm going to give you the data. I'm just trying to find proper information. Just that's there. where they put this information? I remember that I shared that with you at some point, but I can't remember where I did put that. I don't remember.
Well, I mean, if
Yeah, we went through that and at some point,
Oh.
and I will have to tell you where to get that information again.
yeah, I don't want to.
I remember I put the indication somewhere how to do that.
Okay,
Do you remember, Rodrigo?
Sorry, I was making the test. I did not completely understand what you are looking for.
The steps to install what is needed for DOS 101. Where did I put that?
Okay, let me see. I think it's in the channel, but I will double check.
I put in the channel, maybe.
Yeah, I can always look for it afterwards in the.
I
think it's in Crates.io.
Ah, yes, you're right. It's this one. Yes, that makes sense now. Ah, there you go. Thank you. That's yeah. If you need to run this command in the data directory, stuff I will go to in Slack.
Do you mind copying that into Slack?
Yeah, in Slack. Yeah, I'm doing right now. Okay, you need to copy that, and then.
Do I need the next command as well?
Yes, the tar.
Okay.
Yeah, I put the two commands there. So you should download what you need, unpack it, and then you go one step down in the DOS. So you should have DOS 101 and the data directory, and in this directory you should unpack the mode, and then you go one step back, and then you can run after that.
So I do this in the data directory?
You unpack, yes, you put the data in the data directory.
Oh, okay, and then I go back to DOS 101 and then I can run it. Oh,
yeah.
Okay.
Okay, I will continue.
Yeah.
So I was talking about the get method to get the data, accessing that. And why I ask you to do that is because if you look at the list of methods in Arrow, there's no get method. And that's something that confused me at the beginning when I was using Rust, because I was looking in the method and I couldn't find the method that people were using it. In fact, we need to look also at the trait implementation. The traits are very often a kind of treasure trove of additional functionalities. And here you have a get trait. And the get trait implements the get method. And what's put on the record field, don't you? So it's fair. The traits are some things that I used to overlook at the beginning when I was using Rust or reading the documentation. But in fact, there's a lot of additional functionalities that are there can be useful to look. So it's always when you look at the documentation of a new structure, of course, we start with looking at the methods and the fields if some are available to you, but also have a look at the at implementation, because here you can find things that, and here the get function was a bit hidden there, but otherwise it's just expect the field name, but this time as a string. That's all. Okay. Okay, I will going to move to the main branch and merge my commit now of the solution. Okay, check out one main. Check out main. Sorry. Yes. Check out. Check out main and git merge solution. Okay, so I'm on the main branch as well. So now we're going. Christoph, how are you doing? Is it running?
No, I strangely still get the segmentation fault. So I copied the downloaded the file to the data folder, and then I ran the tar in that folder, and then I moved back to the DOS 101, and I did the export command there, and then the cargo run, and it's still the segmentation fault.
Can you share your screen again?
Mm-hmm. I mean, I did also copy the file here, but that shouldn't. Oh wait, is it not?
Yes, the data is not in the right. Is that where you expect it? Doesn't really matter, but.
That is weird.
Yes, data. It doesn't matter. Go to. Go to data. Can you go ls there? ls in the directory. Okay. So now if we go to, we're going to do export again.
Oh, it doesn't.
Yeah, no, but the path is wrong. The path is wrong. So we're going to have to type the path now.
Oh.
Because you didn't put the data in the right the data folder in the right directory. So you can move the data folder into DOS 101 if you want, instead of changing the export.
Oh, but should I just move the data in the right folder?
Yeah, that would be
easier.
Yeah.
So is it this data that I need to move
the
to?
folder, the data folder.
Oh, should the data folder be under DOS 101?
Yes.
Oh, I see.
Yes.
It
Now
can be
try.
outside, but then you need to export the proper location.
Yes. So go back to DOS 101. No, in the
Oh, okay.
in the terminal, and then we're going to run again.
And then
I go run. Oh, you need to go to DOS 101.
Oh, okay.
It's running and segmentation fault.
Yeah. But do I need to do the export stuff
again? Yeah, because I think you run it at the wrong place and it get. Yes. Okay. And then because PW gets you the current directory, cargo run. And segmentation fault.
Do I need to do the tar thing?
Look, do ls data. Can we do ls data?
Yeah. Here?
Yeah, ls data. You cannot access data. What? Yeah, okay. I don't know where is your data folder. Yeah.
Yeah,
I don't
because
know
when
what.
I look at this panel, it
Yeah.
looks like, somehow there's like a double.
Double data.
Yeah, there's a double DOS 101. There's a folder in DOS 101 called DOS 101, and that's where I put the data, I guess.
I think you just need to go, if you type ls, just to confirm that you need to, and then we can go.
Okay, so do move mv, so just mv DOS 101 / data,
Slash like this.
data, space dot, and return. Okay, ls again, and cargo run.
I don't need to do the export first.
No, we did. Try again. No, do it again. Export again. Here. And again. Oh, can you do ls data? Go to data, and you need to enter in data.
Oh, okay.
Call the tar command data in Slack. Okay, go back to DOS 101 and cargo run.
Do I need to do the export first?
No.
Okay.
Just cargo run. Oh, come on. ls data again? The mode are there. Try the export again. Export. Cargo run again? Really doesn't like it.
Your export is spelled slightly different.
Here we go. This time it worked. Good.
Like these little symbols around the PWD. I think I was using the wrong.
Yes, because depending on the type, PW is a command, in fact, that we put together. Okay, here we are. Okay, I'm going to share my screen again.
I don't think you're sharing your screen.
Not yet, not yet.
Oh, there's my image. See the blue pale dot.
It's yours. I started. Okay. So I think we are more or less on the same page. So I was talking about the get method. That makes sense? The get method? How to get it?
Yeah, look in the trade.
Yes, looking at the documentation, the trait implementation, exactly. Okay. All right. So now we're going to try to add the atmosphere now. So we're going to see how to create an atmosphere and an atmosphere to the model. So if we go back to client CEO, optical model builder, we have to go back to the options and the optical model options here. And we see that we have an atmosphere. So we just need to add that to our vector of options. So it's going to be another element here. So it's going to be optical model option, and we're going to add an atmosphere. Okay. So it already did a few things for us here. So let's explain first the time step. So we're going to have to sample the atmosphere at a given rate. So we need to specify the time step that we're going to, because we're going to have a live atmosphere. So we're going to specify maybe 5 milliseconds to start here. And we need to specify the builder as the atmosphere builder, which is, if we click there, we send to back to ratio, and we're going to build atmosphere builder. The change I made to ratio is because proper way to build a builder is from the class atmosphere itself and call on it a builder. So it's a proper way to do it. And that should create for us a default atmosphere. Which is going to be the default value, the default parameter. Usually I put the default parameter somewhere here in the default trait. So here we have the default parameter for the atmosphere, which is the standard atmosphere for the GIMT. If we build that, let's see that build, cargo build. It seems to be building.
Rod, can you tell again the meaning of the time step setting?
So as we iterate through the model, we iterate through time. So that's the rate, the delta t between two updates of the atmosphere. So we're going to have atmosphere at t equals 0 at 5 milliseconds, 10 milliseconds, etc., etc.
Oh, okay. Okay. But how this setting relates with the timer?
So the timer doesn't have any notion really of time duration. It's a digital clock. So it's 1 sample, 2 samples, 3 samples. So that's why we need to specify between two tick of the timer how much time as we append, and we see the time step.
Okay, so the atmosphere is going to be faster. Okay, not faster because we don't have time interpretation on the ticker.
Yeah, the timer doesn't. I built the timer such as it's just given a beat, and there's no option of time. And then after that, in other part of the simulation, we can specify between 2 beats how long, what is the time duration. It's what the time step is.
Let me explain why I asked that. So for me it's clear that with the timer, our system is going to follow the number of steps that we set as the duration of the time. But now that you have the atmosphere, it seems that we have something is not synchronous to the previous example. So something is happening in between the timer. Is that correct?
No.
No.
No. Before,
for example, we have the duration as 2.
Yes.
So it means that we are going to have in the output the detector frame in 2 instants, right?
If we put 2 where, sorry, 2 where. In duration.
Exactly.
Here, yes, we can do that too.
So in this case, we are going to simulate the system we are going to have two samples.
Two
right,
samples,
of
yes.
the detector frame.
Yes.
And for each of those two samples, how the atmosphere set to 5 milliseconds is going to affect those two samples of the detector frame.
Okay. So, so the first sample, the atmosphere is in the original state. You get a representation of that. And then the atmosphere is composed of discrete layers at different altitude. And at each layer is associated a time speed. Sorry, a wind vector, a speed, a speed vector. And so for the next step, we move all the layers according to the wind vector and the duration of the time step of 5 milliseconds. And then we compute the atmosphere again.
Oh, I see. So this, if I got correctly, this 5 milliseconds has nothing to do with the throughput of the information or how fast we are making ray tracing. It has just to do with the profile of the atmosphere that you are creating.
With the time evolution of the atmosphere, yes.
Okay, okay.
It's just a property of the atmosphere. That build, that should even maybe run. We can try. It's running. Yeah. It runs with the atmosphere. Fantastic. Let's look at. Oh yes, if you look at the output here of the wavefront error, you see before it was less than 1 nanometer. Now we have 1.2 micron, which is what you expect from the atmosphere. And you see it has changed from one step to the next because the atmosphere has effectively changed. Let's see the image forming. Okay, what are we going to see? So let's load the data again. Oh, here is the image. But of course, we go from a high telescope, a large telescope, and now we have the atmosphere. That you have to remember that the atmosphere is typically equivalent. The resolution you get to the atmosphere is equivalent to using a 10 or 20 centimeter telescope. And here we are, before we are using a 25.5 meter. So we're going to change, we're going to reset our Stack-Hartmann to the default configuration with a larger field of view and run it like this to try to capture the whole image. I will run in release mode. It may be fun. It will take some time to compile, but it may run faster at the end. Yes, let's do that. Can I get the? I don't think I have. I'm collecting the wavefront. Let's go back. I don't remember exactly. What do I have in the CCO? Detector, GMT, OptGSM, segment, sensor. Yeah, I should add an option here in name to get really the wavefront. It would be nice to see the wavefront in the QP. Okay, we'll have to add that at some point. Okay, but never mind. Let's start compiling. So you see the default atmosphere is relatively straightforward to get, and we already form an image like that. bit of time to compile this Walrus, but getting there.
Again, where can I find the information about the optical model options to get the atmosphere?
Okay.
It's those actors, right?
So you go to those actors, yes, and
Okay.
you look, and there you go to the clients,
Oh, okay.
and then there you go to CU, and then you to find the optical model builder, that's what you're using, and then there's the options, and so it's a vector of optical model options, and here you have the list of options, and then with that.
Thank you.
Okay, it's running. Okay, we have it. It run in about half a second. And let's see the image now that we have a larger field of view. Let's reload that. Oh, yes, I know. I'm doing something wrong because the image is now 512. Up. What am I doing wrong here? Totality from shape. 496. What am I doing wrong? Yes. Yes. Okay. The image is 512 and I have to reset the parameter because the 512 is set also in the log n here and we didn't get the right size, so we get something a bit wrong here. Okay, never mind. It's once again, don't go too long, just okay. So now that should be okay now, the right size of the image. Yes. Here we go. So I'm going to make it bigger. Axe. To the figure. Let's cube plots. Each size equal 10 over 10. And we're going to use axe. Okay. So now we have an image. Let me see. Nice. So that's really what, so we go from a little dot to what we are saying now. And so our objective is to go from a diffraction limit telescope, put the atmosphere, so we don't see we lose resolution, and then we're going to step by step build an adaptive optic system to go back to the resolution we want. What happens if we go a bit more steps? So if we go, so half a millisecond, if we go maybe 200 steps now, let's see what's going on here. And, oh, well, we have something nice we can do too. We can tell him to have a little progress bar. Sometimes it's when it's slow, it's useful it works only with the timer, but it's something useful to see. So let's go 200 steps. So in total, we will have the time step being 5 milliseconds is equivalent to 1 second. Yeah, there's a little bug in the progress bar. You see, you put it twice. It should not happen. I have to figure that out. But that's a detail, really. I will have to fix.
So it basically we're just running the observation longer and integrating out the
exactly
disturbance from the atmosphere.
Exactly. So all the images always are in exposing mode. So unless you explicitly reset them, you are in you are integrating them, and I want just to show you the effect here. Okay, so it's done. Let's see what happened. Now we have after 1 second. What is the size of the detector frame? 512 by 512. I want to have the last. Oh yes, okay. Yes, I will remove that for now. This one. Like this, we can see the image. So this is what I showed you before is the first image. So we can look at the last image now after 1 second. Should be 199, I guess. Yes, that's it. 199. You see, we have integrated. So we are summing. So we start to form a kind of nice smooth Gaussian. Okay. So it's always interesting to see what you get. Yeah, at the first sample you get, and then if we go 10 samples later, then we start to accumulate. So they start to fill a little bit, and then. So what is interesting here, if we go back to the first sample, you remember when we run the model at that the model with that frame resolution without atmosphere, we add a dot, right? The image. In fact, each dot here is at the resolution of the full telescope. Because you can see that we are breaking the wavefront on the whole telescope in small pieces, but each we still have the full resolution, but it's all break in small pieces, and they move randomly. So when you integrate, then you get halfway through you get this smoother and smoother image.
So is that why all of the observations are like 15 minutes or something like that?
No, this is more it's more for science, because they observe faint object, and so they need to integrate longer.
Oh, okay.
Actually, I think that with the adaptive optics, we are supposed to compensate almost all of the effect of the atmosphere, right?
It's yes, and we will see that. It's what we're going to work on. Okay, that makes sense with respect to the atmosphere. So you see, it's relatively straightforward. You just add the default atmosphere. We may tinker with the default at some point, but just like that, and then just specify the sampling time of the atmosphere here, 5 milliseconds. Okay. I will go back to just a few samples right now. I'll pick 3. Because I want to remove progress. Yes, I need to have progress when we go for small. I want to add. Oh, we're going to add another optical model. That this one will be used for will be the adaptive optics channel. So the way to do that, we can just copy the model here, and we're going to call this one adaptive optics. And for now, we're going to not change anything. Like this, we can see that we can run them concurrently. So this is going to be adaptive optics. Yes, just like that. That should work. We need to change anything, and we just need to. So we just need to connect the timer to also this one. So we need to add another output to the timer by multiplexing it, multiplex 2, and we so when we do that at the output of build, we get for the same output of the timer, we get 2 inputs that we need to assign. Adaptive optics. And by using the framework, I realized that sometimes when I developed sometimes I add I multiplex an output and then I unmultiplex it and then I remultiplex it and so on to try. And sometimes I do forgot to add or remove an output. If you multiplex, for example, and you don't add as many inputs as the number of multiplex, you won't have any warning of errors or anything like this, and that can be a problem. So I created a function to check for that for us. So you can ask, it's optional, this function, but you can do it like this. Confirm. So here this function just checks that the number of outputs that we add to this actor, all these outputs have effectively been affected to the right number of other actors. It's a nice runtime check that can save you some headache sometimes finding some error. And if it fails, then it will return, the program will crash, it will return an error. So that, and I'm going to also just add that's interesting. I'm going to create a new logger for this one. Let's make a new logger. We're going to do the same. AO login, AO logs. Like that. Time is we started a bit late, so if you don't have any issue with that, I will continue. And I'm just going to add not just one output for now to the adaptive optics. Add output build with front error MS, and we're going to put that to the AO logs. Yeah, just like that for now. So, and we need to add our adaptive model here. Adaptive optics model. And just check the output of the AO logger, make sure that nothing funny happened. So we repeat that as well. Let's run that. Yeah, that's building apparently. Okay, so let's review what we did. So we just copy the optical model, just give him a new name. Really, we didn't change anything. We copy the logger as well. We add another output to the timer to trigger also the new optical model. So we need to add an input here and then just introduce this function which will check that the output here. What happened is that at the end of after a build, you get a vector of inputs that you're going to assign. And normally, if you assign enough input, the vector becomes empty at the end because the vector is also outputted here and here. So confirm, just check that it's effectively empty. That's no problem. Okay, so our model is running. Let's see what's going to happen. Oh, it's hanging. Yes. Why is it hanging? Interesting. Who can tell me why it is hanging? It's right. It doesn't move anymore. It should have moved. But I forgot. it's nice to have to do mistakes too, like this, because I know I forgot to add the AO logs to the model. So that, we connect the adaptive optics to the AO log. So it send that the AO log, so it sends something, and but there's nothing that been started yet to receive it. So it just hangs in the balance here. So we're going to run that again. And we should have been able to see that by looking at the preview here. You see in the model, we have one arrow. Oh, okay, we have only the arrow corresponding to the on-axis GMT, not to the adaptive optics. So looking at the image also would have been, oh, it's done. If we open it, open preview again. You see now we have two arrows. One from the on-axis and adaptive optics, and sending the wavefront RMS to their respective client. And we can see that they're both outputting the same wavefront RMS for the 3 steps. So
why you have a kind of a dot connecting the wavefront error RMS coming from the adaptive optics and the on-axis GMT?
It's a bug in the graphic generation, the graph generation algorithm. It's something I have still to fix. Something I have to work. There should be. It's in fact an interesting and tricky problem. When you have the same output name sent to different clients, I need to find a way to remove the ambiguity, because I'm using the name in the graph to identify things, but I need to. And in fact, you see the arrow. I don't use the name. I define a unique number that I can. But for some reason, it's a bit difficult to do for the input and output name. So it's something I still have to do. Normally, you should have not have you should have 2 dots and they should not be connected. Okay, so we may want to stop here for today. So we're working our way towards building an adaptive optics model. So we add an atmosphere. Today we see that we can integrate up to 1 second, and then we see the effect on the image. We start to create the channel for the adaptive optics sensor part, and with the atmosphere as well. And we log this data. We get the same data that, because it's just a copy and paste of the optical model originally. So everything is the same. Do you have any question here at the stage? No question?
I have a question, but not specifically with those chains. It's something that I was realizing all the time. When you run the model, we have the steps and the hashtag, and then we have 3 numbers. So in the latest
yes.
533.
Yes.
I believe that the first is the duration of the timer, and what about the other 2 ones? What's the meaning of this 3?
This was for more debugging for me. I'm going to remove that because it should be only 1 number. It should be 3, the number of steps. Why 5?
I'm asking that because I remember working on that, and I made a mistake. And when I made the mistake, the numbers were different. I don't know. I'm not saying that there is a mistake here. I'm just saying that I used also that information to check that something was wrong. It was really wrong. And then when I corrected, I got the 3 numbers equal. And I was just wondering the meaning of that. So I just used the numbers, but I was not sure where they come from.
Yeah, I'm surprised of the 5. I have to check. It's more. Yeah, I have to check again in the code itself. I put that here for debugging because it can be a good way for me to trace some issues. It should be 3, I think. So why is this 5 here? Okay, something I have to check again.
To me, it was something to do with, we have the duration of the timer, and we also have the amount of information that we are going to log.
Yes, it is related to that.
Okay.
But it should be, because we have only one scala, the arrow data, this one is 1. This one should be 3, 3, 3. And this is 1, 2, 3. Yeah, there is something fishy here, I have to understand. It seems that maybe it's just the printing that is wrong, because the output seems to be correct, both when we look at the image and the value here. So that's a good point. I have to understand what is happening and probably I will remove these 3 numbers because I think it's working correctly now. I will double check that. Okay, I'm going to stop recording now if there's no more question. So next week what we're going to do is we're going to start to modify our adaptive optics to really turn the Shakhartman into a real Shakhartman, doing some calibration maybe, and then start to implement a closed loop system where we can start to correct for the atmosphere.
Nice.
So we're getting there.
I have one question.